To determine which process we need to use in order for us to solve for this given differential equation, whether the process for exact or non-exact, we need to establish whether this given equation is an exact differential equation or not. We need to show that this equation, when transformed into m of x of y dx plus n of xy dy equal to 0, we need to establish that a certain partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. If we could establish this equivalence, then we can say that our given equation is an exact differential equation, and hence we'll be using the processes intended for that same exact equation. But if it's not, then we are going to use another method pertaining on non-exact differential equation. So what we need to do here is to identify our m of xy and our n of xy. Of course, our m of xy, the function, is beside or paired with the x, and that would mean this function here, this is 2x plus y. Now for our n of xy, it is the function paired with or multiplied with dy. But let's not forget that our given general form here is plus. Take note of this minus here. This is one of the common mistakes that we might do in determining which functions we need to write. This means that the function n of xy is not x plus 6y, but more importantly, it is negative of the same quantity, because this is under subtraction and our general equation is plus. This would mean n of xy can be written as minus x minus 6y. Okay, now that we have these two, let's try to determine the partial derivative of m with respect to y. This means that we are going to take the first order derivative of m only taking the variable y as a dependent variable. This would mean that if there exists a variable x in the given function, then we are going to treat it as a constant. Supposedly, our given here is 2x plus y. We have two variables, but since we're taking the first partial derivative of m with respect to y, we'll be treating this x together with 2 as a constant, and hence its first order derivative, since this is a constant, will become 0 plus the first order derivative of y, which is 1. This would mean that this is equal to 1. Similarly, for the partial derivative of n, that's n, with respect to x, we'll be treating y as a constant here. So for this given equation, this will be treated as a constant, hence its first order derivative would be 0. The first order derivative of minus x is minus 1 minus 0. This gives us negative 1. So we can see here that the partial order derivative of m with respect to y is not equal to the partial derivative of n with respect to x, because this is 1 and this is negative 1. See that if we were not able to consider the negative earlier and we are going to consider this only, this would become positive, and we might say that this equation is an exact equation. But as mentioned, we need to make sure that we are going to consider the negativity as what's given in our equation. Hence, this time we can now say that the given equation is not an exact differential equation. Hence, we are going to use the process of solving this equation using the processes intended for non-exact differential equations, which will be part of the next video. So please stay tuned. Thank you very much for watching.